Unit 3, Stretching and Shrinking, Investigation 1. Today we're going to look at two figures. They are similar figures. One of them is smaller and one of them is bigger. We're going to start by looking at what they have in common and what's different. So keep these figures in front of you as we answer each of the questions. All right, so how are the two figures alike and different in the shapes that make them up? So if you go and look at your two pictures, you should realize that they're made up of the same exact shapes. In fact, if you were to shrink the one, you could actually make them identical or enlarge the other one. So the two figures are made up of the exact same shapes. The only difference is that on the larger figure, the shapes are larger, and on the smaller figure, the shapes are smaller. All right. So how are the lengths of the line segments the same and different? Well, they're the same general, again, shapes going on, but if you do some comparisons of the different line segments, you're going to realize on the big one, if you look at the hypotenuse of the triangle, which is the angled side, it is 95 units long. Versus if you look at the hypotenuse of the smaller triangle, it's 47.5 units long. So what happened is that the lengths from the smaller shape to get to the larger shape are double the size. And if you do the comparison again with the shorter side of the rectangle, you're going to see the larger rectangle has a length of 18 and the smaller rectangle has a length of 9. So to go from smaller to larger, you have to double the size. Now, what if we want to look at the area and perimeter? Well, that's a little more involved, and we're only going to focus on the area, perimeter of the rectangle that makes up the hat and the triangle that makes up the body of our shape. So what I'm going to do is start with the perimeter. All right, so I'm going to start with the perimeter of the rectangle. Now, I am going to tell you, you're going to need to do this set of calculations twice, once for the rectangle and then once for the triangle. Okay. So I'm going to focus on the rectangle to start with because that's usually the easiest one for everybody to work with. All right, so just make sure you don't write large because you are going to have to fit a little bit of information in this space. If you do run out of room for some reason, you can draw arrows down to the bottom, or you can get a piece of binder paper from on top of the bookcase and add in extra paper to your notes. All right, so let's go with the perimeter of the larger rectangle. To do that, we're going to go 18 plus 18 plus 38 plus 38. That's the larger rectangle. All right, so if we add up all the sides on the larger rectangle, we get 18 plus 18 plus 38 plus 38, gives us 112. Now I'm going to do the same thing, but this time I'm going to go ahead and look at the smaller rectangle. So I'm going to do that down here. Smaller. I'm going to put an S, so ignore that S up here. For some reason it won't let me erase. So this is the smaller one. So we're going to do the same idea. We're going to go 9 plus 9 plus 19 plus 19. If you add all of those up, you get 56. So how do the perimeters of the rectangles compare? Well, the perimeters, if you look at it, the perimeter of the larger rectangle is 2 times that of the smaller rectangle. So let's try this with area. Let's see what happens if we try this with area. So again, I'm going to start with the larger rectangle. Remember, to find area of rectangles, I take the length and the width and I multiply them. So I'm going to take 18 times 38. And let's see what we get. So when I found the area of the larger rectangle, I got 684. If I go in and do the same thing with the smaller rectangle, you'll notice I get 171. Now, it's a little trickier to see the connection between the areas, but if you take the smaller rectangle and multiply it by 4, that gives you the area of the larger rectangle. And the reason is it takes 4 of the smaller rectangles to fill up the larger rectangle. So the area of the larger rectangle is 4 times the area of the smaller rectangle. All right, so here's what I want you to do now. I want you to try this out with the triangle. See if the same holds true for the triangle. All right, so remember that if you're trying to calculate the area of a triangle, that you take the base of the triangle times the height of the triangle. And remember, these are both the straight sides of these triangles. You're not looking at the hypotenuse. And then you divide the whole thing by 2. So go ahead, take a few minutes now and do that. Go through the triangles and find the area of each of them, and then find the perimeters of each of them and see what you get. So pause the video at this point, calculate that out, and then I will give you what the answer should have been. So if you did your calculations, you should have got that the area of the larger triangle is 2,137.5 units. The area of the smaller triangle is 534.375 units. If you multiply that 534 by 4, you will get the area of the larger triangle. So far, the pattern that we found with the rectangles applies with the triangles. The area of the larger triangle is 4 times the area of the smaller triangle. All right, so now let's take a minute and look at the perimeters. All right, so remember real quick before you do the perimeters that all you have to do is add up all 3 sides of the triangles. No fancy calculations here, just add them up. All right, so if you calculated your perimeter correctly, you should have got 227 for the larger triangle and 113.5 for the smaller triangle. If you compare those two numbers, you'll find out that the perimeter of the larger triangle is 2 times the perimeter of the smaller triangle. So far, our larger picture is double the size of our smaller picture. And it doesn't matter what part you're comparing, the same pattern is showing up. The perimeters and the side lengths are always double here, and the areas are always 4 times when you go from smaller to larger. All right, so for part B, we're going to go ahead and do the same kind of comparisons here for these triangles. I'm actually going to only have you compare the lengths and the perimeters just to make this go a little faster. So if you look at the lengths of these 2 triangles, what do you see? Take a minute, pause the video, and write down your observations. All right, so if you look at the side lengths, you're going to notice that if you go from the larger triangle to the smaller triangle, you have to cut all the side lengths in half. Versus, if you look at the side lengths where you're looking at the smaller one first and then the larger one, you have to double the size of all of the side lengths. So there's 2 different comparisons you can actually do here, from bigger to smaller or from smaller to bigger. All right, so if you go through and calculate the perimeters of each of these, you're going to figure out that this one has a perimeter of 22, and this one has a perimeter of 11. So here's the thing. The perimeter from the larger triangle to the smaller is half the size. And if you go from the smaller to the larger, you're going to get that it's 2 times the size. And if I was to have you calculate the areas, you would find out that the same pattern from before happened, that the areas here, because the figures, the bigger one is double the size of the small one, the areas would be 4 times the size if you went from smaller to bigger. All right, so for this part, we're going to go ahead and look at what happens in really fine detail when you start scaling things up or down based on a set percentage. Okay. So we're going to take what you did in the last section and we're going to move forward into this new one. So to start, we're going to talk about corresponding sides and corresponding angles. When two shapes have corresponding sides, such as side A to C right here, and side D to F right here. You notice that this side and this side are on the same side of the triangle. They both come off of what appears to be a 90-degree angle. Then you have side A to B here, and side E to D here. Again, they both come off the 90-degree angle in the same direction. And then finally, you have side B to C and E to F. So what these are the sides of the triangles that match up. If you turn your shapes the exact same way, you can then find the corresponding sides because they're the sides that would be facing the same direction. The angles work the same way. If you turn your shapes so they're facing the same way, noticing both these triangles have a short flat bottom with the nice, what appears to be 90-degree angle on the left-hand side. So if we look at angle A and angle D, they're the same angle. If we look at angle C and angle F, again, they're corresponding. They're going to be the same angle. Angle B and angle E, same thing. They're going to be the same angle. So we're going to use these ideas today to make some comparisons. All right, so for today's lesson, we're going to use these 3 figures. We have the original drawing up at the top that I've labeled all the parts for you. We have the drawing that was copied at a 75% scale factor. And then we have the drawing that was copied at 150%. You probably can look at these and realize that the 75% one is smaller than the original, and the 150% one is larger than the original. But we're going to take it a little step further and look at how that affects the side lengths, the angles of these shapes. All right, so we need to figure out first is how to describe how the side lengths compare to corresponding side lengths in the original figure. So go ahead and just pick a side. Now make sure that you're comparing the same sides. And for the sake of what we're doing, we're going to go ahead and compare everything to the original design. So let's start with the original design and the 75% one. What happened to the side lengths between when you went from the original picture to the smaller picture? The side lengths of the smaller design are 0.75 or 75 times as long as the side lengths of the original design. And you can actually figure this out by taking 4 and multiplying it by 0.75. So if you wanted to calculate this out, you would go 4, which is the original, times 0.75, which is the copied percentage, and that gives you the size of the new side. Now what about with the larger one? What happens with the larger design? So for the side links of the larger design, they are 1.5 times as large. And that 1.5 comes from the copy percentage. It's when you change the percentage of 150 into a decimal. So they are 1.5 times as large as the side links of the original design. If you wanted to calculate this, you could use the same side I did earlier, which is the side of 4 centimeters, multiply it by 1.5, and you get 6, or the 6 centimeters from the larger design. So for problem 2, I want you to go back and look at your picture and see what happened to the size of the angles in every single picture. Did anything even happen? Make sure you look at all 3 angles and make sure that you're comparing the correct angle. Keep your pictures oriented the same way and compare your angles. Hopefully you noticed that the angle measurements didn't change. All we've done to this picture is increase the length of it, but we haven't changed the actual measurements of where the lines run into each other. So all we did was scale the picture up or scale the picture down from the original. In scaling a picture up or down, it does not change the actual angle measurements. Everything still meets at the same point. It's like on a model car. If they take a large car and shrink it down, the tires are still in the same place. They don't move. So the angles on these pictures don't move because they're still in the same place. It's just how long, or in the case of like the car, how wide the tires are that change. But the tires are still in the same place when you look at the vehicle. So for problem number 3, we're going to look at the perimeter of the triangle. So we're going to look at the perimeter of the original triangle, the perimeter of the 75% triangle, and the perimeter of the 150% triangle. And we want to see what happens to the perimeters each time. So go through now and calculate the perimeter of each of those triangles. Pause the video, do your calculations, come back and check to make sure you got it correct. Alright, so hopefully you got 12 for the original, 9 for the 75, and 18 for the 150. Now, how do each of those new ones, the 75% and the 150, compare to the original? So if you do the comparisons and you take those percentages and turn them into decimals and then multiply them by the original, you're going to find out that the perimeters have the exact same pattern that the side links did. The perimeter for the 75% one is 0.75 times the original, while the perimeter for the 150% one is 1.5 times the original. Now what if we go and look at the areas? Well, take a minute and calculate the areas for these 3 triangles, and then let's do some comparisons. Alright, so hopefully you got 6, 3.375, and 13.5 for your areas. Now what does this tell you about the areas for these triangles when compared to the original figure? It tells us that the area of the smallest design is a little more than half the area of the original design, while the area of the largest design is a little more than double the area of the original design. Alright, so how do the relationships in size comparison you made in question A relate to the copy or size factor used? Well, think about it for a minute. Go back and look at question A and see if you can come up with an answer for how this works. So hopefully you realize that the length and the perimeter comparison factors are the same as the copy or size factor. So in the case of our 2 problems, the smaller design was copied at 75%. That meant the links in the perimeter were 75% smaller. Or you had a scale factor of 0.75. When you look at the 150% one, they were 1.5 times larger, or that is the decimal of 150%. Alright, so this wraps up the video for today's lesson. Make sure you pick up your homework off the table in the front of the room, and you may start working on your homework if you have some time left in class today. We'll do a short debrief on Monday morning.